Assalamu alaikum. I am Adil Iftikhar here with the third lecture of DSP. In this lecture, we will cover some types of systems, properties of systems, convolution, and its application. Now let's start. Now, what a system does? System processes a signal to create other signals simply. Now consider this: an input is applied to a system to get an output. Now here are some types discussed here of systems. First of one of them is serial or cascaded systems. What happened in serial or cascaded system? Systems are connected end to end when applied input to get desired output. Now what is a parallel system? Here is the block diagram of parallel systems. In this, the systems are connected to each other and we have an applied input to get an output desired. Now what is a feedback system? In the feedback system, we have a feedback coming from the output to the input to get desired objectives. Now here are some different types known as coil systems and non-coil systems. The coil system depends upon the current and the previous values, whereas a non-coil system depends upon only the future values. These are the formulas of coil systems and the non-coil systems, and we will use these formulas to solve some examples. Now consider this example. We have solved this example and it shows that it is moving towards the left side or it is shifting towards the left side of the origin. So it means it's a non-coil system. Now we will further move toward the linear systems. For a linear system, it should be additive and homogeneity. Now what is additive and homogeneity property? We will further discuss it. Now come towards the additive property. Additive property is what when we apply some effect or add some effect on the left side to the input, we have the same effect applied onto the output and it has no difference. This is known as additive property. Consider this example: x1 of n corresponding to y1 of n and x2 of n corresponding to y2 of n. If we add them, we have the same desired output we have the same effect on the output. This is known as additive property. The next property is to be satisfied is homogeneity. Now what is homogeneity? If we multiplied something on the input, we have same thing multiplied on the output and there is no difference in the input and output. It is known as homogeneity, and we have to prove the both of things to show that a system is a linear system. Now consider an example. We have given this example. Now we have to show that it satisfies only both of the properties known as additive properties and the homogeneity properties to show that it's a linear system. We have solved here. First of all, we have proved that it is an additive property, and then we have shown that it is a homogeneity property also. So it's a linear system. Now consider another example which is given here: x of n plus 5. First of all, we show that it's additive or not additive, and then we show that it's homogeneity. First of all, we have shown that it's not additive, simply it's a non-linear system. Now one thing to remember is that if we apply threshold, so simply it means it's non-linear system. Now another type comes which is known as time invariant system, which shows that if we apply some time interval difference on the input, we have a same difference or a same effect on the output. Now we will take some examples to show that this is time invariant or non-variant. For example, consider the example xn plus 3. If we are applying the same effect on the input, we are getting the same output. So it means it's a time invariant system. Some examples of time invariant systems are fan and internet. Now consider another example to show that it's time invariant or non-variant. We have these examples. The first one is simply a time invariant examples. For example, whereas on the second one is a square one. If we open the square, we have some different values, so it's a non-time variant system. Now we are moving towards another topic which is known as convolution. This is the formula of convolution. We have a signal and another shifted signal multiplied to get the output. For example, this is the shifted versions. Now we will apply a convolution example. This is the formula of convolution, and we have applied the convolution to the previous example. We have this formula to apply it on this. Here the graph discrete, and these are the values we have got. After applying convolution, we have the discrete values here. These are the values and these are the outputs. Now we can apply it to another examples by using the shifted versions of the output. These are h minus k or h plus k, and we have the outputs -1 1 1, 3 minus 2 1, 1 minus 2 and 3. Now what is the difference between convolution and correlation? In convolution we use flip and slide, whereas in correlation we only slide. In the end, we have some applications of convolution. These are measuring similarity of signals, pattern recognition, signal detection, extract radar signals, weather forecasting, weather traffic monitoring. So these are the applications of convolution. So this was the lecture of today. Thank you.